Okay, Chapter 2 is all about working with fractions. And 2.1, the objectives are write an improper fraction as a mixed number, write a mixed number as an improper fraction, write equivalent fractions with larger denominators, rewrite a fraction so that it is in lowest terms, and solve practical problems involving fractions. So I've got kind of a picture here of that describes fractions, and you can see this board is just one whole board, and then the blue part of this board, they basically cut the board in half, so we've got two parts, so we would consider this blue part 1/2. Now they've cut it into three parts, so we would consider the blue part 1/3, and then we've got four parts, so we would consider that blue piece 1/4. Here's an example. How would you label this portion of the area? Okay, so we're going to talk about really quick. We've got you can see the part that's blue. It looks like it takes up 3 spaces. The part that is white takes up 2 spaces, and if we talk about the whole thing, we've got 5 spaces. So we're really just going to focus on the part that's blue right now. So the numerator of that fraction would be your part that you're talking about. So the numerator would be 3, and the denominator would be 5, because that's the whole part. So when we talk about this fraction, we would say 3/5. The numerator is always on the top and the denominator is on the bottom. What is the difference between a proper and an improper fraction? Okay, a proper fraction, the numerator, in a proper fraction, the numerator is smaller or less than the denominator. Here's an example of that. 2/3. Numerator smaller than the denominator. That's going to be your proper fraction. Okay, in an improper fraction, it's the opposite. Your denominator is larger than your numerator. An example of that would be 4/3. Okay, a mixed number is like 2 1/3. It has a whole number and then a fraction attached to it. To write the improper fraction 13/5 as a mixed number, divide the numerator by the denominator and form a new fraction as shown. Okay, so the first thing you want to ask yourself is, how many times will 5 go into 13? Evenly, okay? Well, 5 will go into 13 evenly 2 times, right? Because 5 times 2 is equal to 10. And then you're going to, so that's going to be the first part of our, that's going to be our first part of our mixed number, the 2. Then you're going to say, well, what's the difference between 13 and 10? And remember, difference means subtract. So what's left over? If we do 13 minus 10, we would get 3. And so that's going to be the numerator of our new number that we're writing as a mixed number. But the denominator is going to be exactly the same. Okay, so what we did was we asked ourselves, well, how many times will 5 go into 13 evenly? We came up with 2. 5 times 2 is 10, and then we said, what's left over? 13 minus 10 is 3. That gave us our 3, and then the 5 came from what we already had. So it says we want to rewrite the mixed number 2 3/5 as an improper fraction. So now we're going backwards. So if we take the number 2 and 3/5, and we want to write it as an improper fraction, so top heavy, right? We're going to take the number on the bottom, which is the numerator, and we're going to multiply it by the number out front. So we're going to do 5 times 2. We're going to get that answer, which is 10. And then we're going to take that number and we're going to add it to whatever is in the numerator, which is 3. And that's going to give me 13. And so that's going to be my new numerator. My denominator is going to stay the same, and it's going to be 5. Okay? Equivalent fractions. Two fractions are said to be equivalent if they represent the exact same number. So we've got some equivalent fractions down here. So 8/16. Right? I could divide the top by 8 and the bottom also by 8, right? If you're dividing by 8 over 8, that's just 1, so it shouldn't change the number. 8 divided by 8 is 1, 16 divided by 8 is 2, so 8/16 is equivalent to 1/2. We could take our 4/8, we could divide both of those by 4, which is just 4 over 4 is just 1, so 4 divided by 4 is 1, 8 divided by 4 is 2. So these fractions are all equivalent to 1/2. Rewrite the fraction 2/3 as an equivalent fraction with a denominator of 18. So what they're saying is, we're starting out with 2/3. They want the denominator to be 18. So we're going to say, okay, we can do this. What would I have to multiply 3 by to get 18? 3 times what is going to give me 18? 6, right? So if I multiply by 6 on the bottom, in order to keep it equivalent, I'm going to have to multiply by 6 on the top, because that 6 over 6 is just the same as multiplying by 1, and 2 times 6 is 12. So there's my equivalent fraction with a denominator of 18. So it says, in general, you would write a fraction in lowest terms as follows. So if we start out with 30 over 48, what we're going to need to do is divide as many times as we can by 1 so that we get the lowest term that we can possibly get. So when I look at this, I'm going, well, and some of you are going to be really quick at this, but let's just start slow. I know that this ends a 0, so 2 will go into this. This is even, so I know 2 will go into this. So a lot of times if you're really struggling, just start with, if 2 will work, start with 2. Divide them both by 2. Well, 30 divided by 2 is 15. 48 divided by 2 is 24. 2 is not going to go into 15, and 2 is not going to go into 24. Now, this fraction right here is equivalent to 30 over 48 because we divided by 1. Will 3 go into both of them? Yes. If you really struggle with this, you may have to just type it in your calculator first and see if it's going to go evenly. 15 divided by 3 is 5. 24 divided by 3 is 8. Okay, 5 is a prime number. 8 is not prime, but because 5 is prime, we know nothing else is going to be able to be divided except for 1 and 5, and that's not going to make this any smaller. So this would be reduced. Okay, so the process is exactly the same for improper fractions. 105 divided by 90. Now they started with 15. I would have probably started with 5 off the bat because I would have noticed that this ends in 0, so 5 goes, and I would have probably taken a little bit more steps. But if you can think of a bigger number that goes into both of them, that's great. Okay. Because this one is a little tricky. Write 6/3 in lowest terms. Well, when we start looking at 6/3, a lot of you are going to realize that 3 will go into 6 exactly 2 times. Okay, but if you don't realize that, you could start with the same process we did a while ago and divide by something on the top and the bottom. And so when I look at this, 2 doesn't go, but 3 goes. So if we divide the top and the bottom by 3, 6 divided by 3 is 2. 3 divided by 3 is 1. And when you get 1 on the bottom, it just means you can write it as 2, because 2 divided by 1 is just 2. Okay, which is the larger fraction? 2/3 or 5/8. Okay, there's a really easy way to do this mentally. Okay, if the closer the number is on the top to the number on the bottom, the bigger the number is. So 2 is very close to 3. 5 is a little bit farther away from 8. If this had said 6/8, then that would have been the larger fraction, but the closer the number is on the top to the number on the bottom, the denominator, the bigger the fraction is. So this one is actually the largest one. Okay, if you really struggle with this, you could go to your calculator and type in 2 divided by 3 and get a decimal. 2 divided by 3 is going to be 0.6, repeating, it just keeps going. 5 divided by 8 is 0.625, okay? And so we know that 0.66 is bigger than 0.625 because this 6 is bigger than this 2. So we can tell by doing it that way too if you need to change them to decimals. A 5/8 inch drill bit is too small for a job, and a 3/4 inch bit is too large. What size drill bit should be tried next? So they said what we have is a 5/8 is too small, and 3/4 is too large. So we need something in between these numbers, right? So what you want to think about is the next number that both 8 and 4 will go into, and that's going to be 16. So we want to go, okay, let's make this fraction. What would we have to put on the numerator, or what would we have to do to turn this fraction into something over 16? So we need something that both 8 and 4 will go into to look at that. What would you have to multiply this by? What would you have to multiply 5/8 by to get 16 on the bottom? Well, 8 times 2 is going to give you 16. If you multiply the bottom by 2, you also need to do the same thing to the top. 5 times 2 is 10. So there's what that fraction would be. We need to do the same thing to 3/4. So you'd ask yourself, well, what do I have to multiply 4 by to get 16? And it would be 4. 4 times 4 is 16, so we would have to multiply the numerator by 4 as well, so that's going to be 12/16. So look, we need something in between these numbers. This one was too small, this one is too big, so the right answer would be 11/16. Okay? Let's go ahead and talk about the next section, which is 2.2, multiplying fractions. The product of two fractions can also be shown graphically. So if you've got 1/2 times 1/3, we could take this whole thing, and this is 1/3 of that, and now we're saying that, so they've taken this whole box, and now they're looking specifically at 1/3, and then they say, well, what's 1/2 of that 1/3? Well, it's just this portion right here. Okay, and if I want 1/2 of 1/3, and I want to look at what 1/6 is, this whole thing is 1/6 of the whole thing. Fractions, when you multiply fractions, it's very easy. I like to cancel out if I can ahead of time because it makes me get the right answer faster and easier. So I would look and see if there's anything on the top that has anything in common with anything on the bottom, and this one does not have that. Well, no, I'll take that back. It does. 2 and 6 can both be divided by 2. If I divide 2 by 2, that's 1. If I divide 6 by 2, that's 3. 5 and 3 don't have anything in common, so I'm pretty much done here. 5 times 1 is going to give me 5. 3 times 3 is going to give me 9. And I want to make sure that that's reduced, so I'm going to look at it and see if those two have anything in common, but they don't. Nothing will go into 5 that'll also go into 9. When you're multiplying a whole number, what I like to do by a fraction, I just like to put a 1 on the bottom. So now I'm going to ask myself, 1 and 1 definitely have something in common, but it's just 1. And then I'm going to look at the 6 and the 8 and say, well, do they have anything in common? Well, yes, they're both divisible by 2. So I could divide 6 by 2 and get 3. I could divide 8 by 2 and get 4. Now, it just has to be on the top, have anything in common with anything on the bottom. So then I can go straight across. 3 times 1 is 3. 1 times 4 is 4. 3/4 is reduced, so I'm done. Now, this can get a little bit trickier if you're doing this by hand. Most people would change it into, instead of it being a mixed number, they would change it into an improper fraction so it's easier for them to multiply. So we talked about this earlier. You take the denominator and you multiply it by your number out front. So you say 2 times 2, you get 4. Then you take what you got and add it to whatever the numerator is, plus 1, which is 5. And so our new fraction would be 5 over, and whatever is on the denominator, that stays the same. Okay? So 2 has nothing in common with 5 and 3, neither does 4. So this is going to be 15 over 8. This is an improper fraction. If I want to make it back into a mixed number, remember you ask yourself, how many times will 8 go into 15? Okay, and the answer is 1, so we write the 1 out front, and then you would subtract 15 minus 8, and 15 take away 8 is 7, so that's going to be your numerator, and your denominator is going to stay the same. So that would be a simplified answer as a mixed number. Okay, now we've got 2 of them. So I'm going to make both of these into improper fractions so that it's easier for me to multiply by hand. So I'm going to do 3 times 3 and get 9. Then I'm going to add my numerator, and that's going to give me 10. So this fraction ends up being 10 over whatever your denominator already was. Okay, now let's look at our 2 and 1/4. So we're going to do 4 times 2 plus 1, which is going to be 9, and so our denominator stays the same, which is the 4. Now, the 3 and the 9 both have a 3 in common, so I'm going to divide out a 3. The 4 and the 10 both have a 2 in common, so I'm going to say 4 divided by 2 is 2, 10 divided by 2 is 5. 5 times 3 is 15, 1 times 2 is 2, right? And then if I want to change it, this is improper, if I want to change it to a mixed number, I'm going to say, well, how many times does 2 go into 15? And 2 goes into 15 7 times with 1 left over, because 2 times 7 is 14, and 15 minus 14 is 1, and then I leave my denominator the same. In retail management, goods are often bought and sold in quantities of dozens and fractions of a dozen. Suppose a layer purchased suppose a buyer purchased 1,423 dozen shirts for a clothing store, and she needs to calculate the total number of shirts purchased. Well, we need to know what a dozen is, right? A dozen is 12. And so we just need to do 1,423 times 12 to figure out that answer. So $17,076 shirts. Okay, so that's the end of Chapter 2, Sections 1 and 2, and the next video will start with Chapter 2, Section 3.